Hey guys, Mr. Milton here. Today we're going to talk about properties of parallelograms. At the end of this video you should be able to use the properties of parallelograms to find missing side lengths and angle measures. Okay. Reminder, what other quadrilaterals are also parallelograms? Okay. So when we talk about parallelograms, we're also talking about rectangles, rhombuses, and squares. Okay, so we're talking about all these things. Okay, these are all in the parallelogram family. So any of the properties of parallelograms also fall when we're talking about or talked about when we're talking about rectangles, rhombuses, and squares. Okay, so first property, opposite sides of parallelograms are congruent. Okay, and so what we're going to do is we're going to talk through a couple of these with proofs. So proving this, given that ABCD is a parallelogram, we're going to prove that the opposite sides are congruent, that AB is congruent to DC or CD, and that BC is congruent to AD. Okay, so let's go through our proof. First statement, usually just the given. They told us that ABCD is a parallelogram. Okay, ABCD is a parallelogram. Oops, we know that because it's given. Okay, from that we can say, well, since it's a parallelogram, we know that AB is parallel to CD and that BC is parallel to AD. And we know that because that's what our definition of parallelogram means. Or that's what our definition of parallelogram is. Okay, parallelograms have opposite parallel sides. Okay, alright, so I'm going to mark that, mark it here so I can see what I'm doing as I go through. Okay, now anytime you see parallel lines, you should be thinking of alternate interior angles or same side interior angles or corresponding angles. In this case, I can see a couple alternate interior angles. So here I see the angle 1 and angle 4 alternate interior angles, and they should be congruent to each other. Angle 1 is congruent to angle 4 because they're alternate interior angles. And I can also see that angle 3 and angle 2 are alternate interior angles. So they should be congruent to each other. Okay, both because they're alternate interior angles. Okay, now from there, if I'm trying to prove two sides congruent, I'm probably going to be using triangle proofs, and I'm almost there now. I can see two triangles ABC and triangle CDA should be probably what I'm focused on. And in those two triangles, they share the side AC. Okay, AC is congruent to AC because of the reflexive property. And now I can see that these two triangles, triangle ABC, is congruent to triangle CDA by angle side angle. And so because those two triangles are congruent to each other, then I can say, because I'm trying to prove parts of their triangles congruent, I can say that these parts should be congruent to each other. So AB is congruent to CD, and also that BC is congruent to AD. Okay, both of those because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, AB should be congruent to CD. Here we have it. And then BC should be congruent to AD. Here we have it, just by that rule. Setting that up, kind of a reminder from last semester, but works out. Okay. Second property of parallelograms is that opposite angles parallelograms are congruent. So let's prove that. So basically we're going to try to prove that angle N is congruent to angle Q, opposite angles, and also that angle M is congruent to angle P. Again, all we're given is that this figure that we're talking about is a parallelogram. Okay, and that's helpful because now we know that if it works here, it has to work for anything if all we know is this is a parallelogram. So it works for all parallelograms. Okay, so given that it's a parallelogram, we can say, well, hey, the opposite sides have to be parallel. That's what a parallelogram is. Okay, so these opposite sides are parallel. Mn is parallel to PQ, and that NP is parallel to MQ. Definition of parallelogram. Okay, we're saying that's what a parallelogram is. All right. So again, I mark that. Mark that. Okay. So again, we're using parallel lines. We should be thinking same side interior angles, alternate interior angles, corresponding angles. In this case, I can prove this. I'm going to prove this using same side interior angles. Okay. I know that I have two parallel lines, and NM is our transversal. Okay. In this case, NM is our transversal. And so angle, this angle here, angle N and angle M, should be add up to 180. Okay. So angle N plus angle M equals 180 degrees. They're same side interior angles. Okay, that's the same side interior angles there. Okay. By the same logic, really, since NM is parallel to PQ, angle N and angle P are same side interior angles. So I can actually say that angle N plus angle P equals 180 degrees. Okay, by the same logic. So I'm just going to include that in the step. Now, this helps me out because I should see something. These equal the same thing, so I'm going to use some substitution here. Angle N plus angle M equals angle N plus angle P. Notice I just substituted angle N plus angle P for 180 because they're the same thing. Keeping in mind what I want to prove that angle M is congruent to angle P. So I can say that in this next step. If I subtract angle N from both sides, then I'm able to say, hey, angle M is congruent to angle P because of subtraction. And I could do the same thing with N and Q. It would actually be the same steps here, just using two different angles. Okay, and so now we prove that if all we know about something is a parallelogram, then opposite angles have to be congruent. Done. Opposite sides of parallelogram have to be congruent. Okay, the last property of parallelograms that we should know is that the diagonals of a parallelogram will bisect each other. Okay, and so in other words, we need to show that these diagonals, BE is congruent to ED because it's cut in half, and also that AE is congruent to EC. Okay, because both of those would cut each other in half. Again, we start off with what we know. We know that ABCD is a parallelogram. ABCD is a parallelogram. That is given. Okay, from there we will say that we know that the opposite sides, let's say, let me see, I know I'm going to be dealing with these. Okay, parallel to DC. Okay, again, I know that because that is what a parallelogram is. Definition of parallelogram. Okay. Alright, again, anytime you see parallel lines, you should think alternate interior angles, same side interior angles. And in this case, we see alternate interior angles. Angle 1 should be congruent to angle 4 because alternate interior angles are congruent. At the same time, we should see angle 3 is congruent to angle 2 because alternate interior angles are congruent. So, alternate interior angles. Alright. Now, again, we're dealing with triangles and we see these two triangles. We're actually going to use something that we've already proved, or just proved, that we know that AB has to be congruent to CD. Okay? And we know that because opposite sides of parallelograms have to be congruent to each other. So now that's a part of our definition of what a parallelogram is. Okay? So now we've proven that, for number 5, triangle ABE is congruent to triangle CDE by angle side angle. Okay? And so since those are congruent, then now we can talk about some corresponding parts. So now in this next step, I'm able to say that BE is congruent to ED, or DE, because of CPCTC. And I can also say that AE is congruent to CE because of CPCTC. Corresponding parts of congruent triangles are congruent. And so now we've proven that if we just start off knowing that it's a parallelogram, that we know that the diagonals of the parallelogram must bisect each other. So every parallelogram diagonals bisect each other. Okay, so for the most part, you guys will not be asked to prove those necessarily, but if you were, you could. Okay, you might see more problems like this. Okay, find the values of the variables in each parallelogram. So now it's up to us to know what the parallelogram's characteristics are in order to solve for them. So if I'm trying to find x in this problem, I have x's here with the opposite sides. I know opposite sides of a parallelogram have to be equal to each other. And so now I can solve. Subtract 2x from both sides, add 15 to both sides, x equals 18. Here I have the same kind of setup, but here I have x. Luckily for us, we just found x. X is 18. 18 plus 7 is 25. 2y minus 1 equals 25. 2y will equal 26. And y will be 13. Okay. Other side, we have the diagonals shown here, and so we know that we're going to deal with diagonals, and diagonals of a parallelogram bisect each other. So that means that these sides, 3y minus 7, should equal 2x, and x plus 1 should equal y. Now, this last problem was nice because we had x's and 1 and we could solve an x. This one, we can't solve either equation individually, but we can solve it as a system. We just need to use substitution. Okay, because I know that y is the same as x plus 1. So my first equation, instead of saying 3y, I'm going to say 3x plus 1 minus 7 equals 2x. Okay, and now I can solve for x because that's the only value or variable in this problem. So 3x minus 4 equals 2x. I'll subtract 3x from both sides, and I'll get negative 4 equals negative x. And that means x will equal 4. So divide both sides by negative 1. Okay, since x equals 4, I can plug that back into this bottom equation. It was x plus 1 equals y. And so I'll say 4 plus 1 equals y. And so y has to equal 5. Okay, last part of this for this section. If 3 or more transversals or more parallel lines are cut off congruent segments on one transversal, then they cut off congruent segments of every transversal. Okay, so basically in this diagram here, you see that there's a line that goes through three parallel lines, and you see that these markings are congruent. If these are cut in congruent segments, all the parallel lines have to be, all the transversal have to be cut into congruent segments. So if this is 6.7, this is 6.7. If this is 4.2, this is 4.2. And that allows us to answer the questions. So pH is 6.7. Km, 4.2, Km is 8.4. Okay? Alright, so hopefully now you're able to know the properties of a parallelogram. The three that are important is that opposite sides are congruent, opposite angles are congruent, and the diagonals of a parallelogram bisect each other. You can use that information to find missing values for side length and angles. Alright, see ya.